In earlier lectures, we have learned that Android applications run with the processes and they are comprised of multiple components in the form of activities, services, and broadcast receivers. The goal of this section is to expand on this knowledge by looking at the life cycle of applications and activities within the Android runtime system. Regardless of the fanfare about how much memory and computer power resides in the mobile devices of today compared to the desktop systems of yesterday, it is important to keep in mind that these devices are still considered to be resource constrained by the standards of the modern desktop and laptop based systems, particularly in the terms of memory. As such, a key responsibility of the Android system is to ensure that these limited resources are managed effectively and efficiently, and that both the operating system and applications running on it remains responsive to the user at all times. In order to achieve this, Android is given a full control over the life cycle and state of both processes in which the applications run and the individual components that comprise the application. An important factor in developing Android applications, therefore, is to gain an understanding of both the application and activity lifecycle management models of Android and the ways in which an application can react to the state changes that are likely to be imposed upon the during its execution lifetime. My name is Typhoon, and in this lecture of our Lifecycle course, you will learn about the Android lifecycle events. Here we're gonna create some examples. So I'm gonna show you on the Android Studio server here, or Android Studio development environment. So we have several process management in the Android applications here. So each Android resource management here. So each running Android applications is viewed by the operating system as a separate process. If the system identifies that resources on the devices are reaching capacity, it will take steps to terminate process to free up memory. So when making determination as to which process to terminate in order to free up a memory, the system takes into consideration both priority and the state of all current running processes, combining these factors to create what are referred to by Google as an importance hierarchy. Processes are then terminated starting with the lowest priority and working up the hierarchy until sufficient resources have been liberated for the system to function. So now in our diagram application, I'm gonna create some diagram to show you more consistently and more explanatory lectures, so you can see how the process management works in Android. So let me change my screen here and disable the full screen and yes, I think yeah. Now I will make this to another here. So now here we're gonna firstly we will have a box here which is gonna have the highest priority and lowest priority in Android. So here firstly at the top of our process management here we have the foreground process. Actually, let's increase the font size a little bit so you can foreground process. We also have the visible process. We also have the let's make it, and we will discuss the process names later here. And here after that we're gonna have 1, 2, 3, 4, and yeah, we're gonna have 5 process names and 5 process priorities here. So first is the foreground process, and let's actually change it here. This is foreground, this is here. and lastly we're gonna make it red. So this is the lowest priority, and this is the highest priority at the top of our seam here. So now it goes like this. At the top of here, this is the highest priority. And when our here, this is the lowest priority here. So here at the top of our processes we have the foreground process. Actually, let's name it here visible. Then it comes the visible process here. Oops. Yes, the visible process, or actually let's make it a little light green maybe. No, yeah, make this light green and make this a dark green here, more darker here. Visible, then it comes the visible process, and after that it comes service process, then it comes background process, and empty process. And here this is the lowest priority here, which is gonna have here, and we'll make it highest priority like this. So here, so this is lower priority and higher priority, or increasing, and make this animation here so you can see more here. Okay, general rows here, and here this is our row 90 here. And like this. So the first I want to discuss about this, actually let's, instead of writing this, so as I forgot that I use the green screen, so it you can't see the green on the this process here, instead of you are seeing the black here. So yeah, that's okay, I think. So firstly, we have the foreground process here. This foreground process, so these processes are assigned the highest level of priority. At any one time, they are unlikely to be more than one or two foreground processes active, and these are usually the last to be terminated by the system. A process must meet one or more conditions or criteria to qualify foreground status. For this, so the foreground status here, I'm gonna write the several foreground status here. So it has this hosted service executing either on create, on resume, on start callbacks. It has a broadcast receiver that is currently executed on receive method. Actually, let's make this here specifications. So as I said, it has a broadcast receiver, and making decrease the size, font size a little bit, so we can see more. And here at the top of the screen here. So in order some process in Android to be a foreground process, it needs to host an activity which is user or use an activity and user is interacting, and we also need to host a service in order to be foreground process. We host a service connected to activity, and we also need to host a service executing either on create, on resume, or on start method here. And it also need to host a broadcast receiver. broadcast need to host or broadcast receiver, and that is and currently executing here, and make this here like this. So I hope this is quite explanatory here. So now we're gonna go to the second here. Actually, instead of writing like this, let's actually add an legit row here so you can see it. And this is our foreground process. And after that, here, then comes to visible process, which we're gonna discuss in next lecture.